So as far as these multiple choice questions are concerned, I don't think there should be or there is going to be any difficulty, because if you look at very first one, it says that okay, what is the level curve corresponding to f of x comma y is equal to 2 for this two variable function. So obviously it is going to be 2 is equal to x square plus y square. Now if you compare this guy with the equation of circle whose center is origin and radius is r, you will eventually know that okay, this is equation of a circle which is centered at origin and radius is root 2. It's not 2, it's root 2. So obviously there are two options, but the correct one is the second one. Okay? And then I think question B is really simple. I don't need to waste time on this one. How about C? Is it a circle centered at the origin or it is an ellipse centered at the origin? Obviously it is not a line, so I'm just striking out this option. So a pair of hyperbolas are circle or ellipse? Ellipse. Okay, so for very basic equations, there is a simple classification. That is, if you have ax square plus by square is equal to c, and for example, I am choosing value of a and b to be same. Let's say 1, then this is an equation of a circle. If the value of a and b is different but both are positive, for example 2x square plus y square, this is an ellipse. This is a circle. But if you do this thing that you take a to be positive and b to be negative, or you take a to be negative or b to be positive, you can graph these, you will get like a set of hyperbolas. You know, a circle looks like this, an ellipse like an oval shape, and hyperbolas either look like this, so it's like two disjoint sets, or they also look like, or should I draw? They look like this, okay? So if you draw or you use Desmos to draw like this function, this is not a function x square minus y square is equal to c, but when you isolate y and then you have, I think, two pieces, one is positive square root, other is negative square root, you try to graph these, you will get these curves. Okay, and parabola is always y is equal to some constant x square. So in parabola, like one variable is squared while other is not. So these are called conic sections. If you have done in geometry somewhere, if you draw a 3D cone and if you intersect that cone with different planes, you will get these different shapes in 2D, and these are called conic sections. We are not discussing more about these. I think part D should be clear. I think part E is not relevant, but in some problems we need to do this thing when we are trying to find the limits. It says that, okay, if you simplify this G, what is the simplified expression equals to? So when you find limits, this trick is very common. You can factorize the numerator to get x plus y times x minus y divided by x minus y, and if you simplify, you will get only x plus y, which is option A. So why are we doing this thing? Because like this thing is coming from your high school, you might have done maybe before high school, and this is a basic algebra question, but we use this type of trick while we are evaluating limits.
For D, would it be the first one?
Yeah. So F is similar to E. So you can think of, okay, the questions would be similar to these, what we are doing here. Okay, so it's like very important to practice on these questions. Okay, how about this one? So e to the x square plus y square is equal to c. This is how we define these contours or level curves. What does this equation represent? Is it like ellipse, a circle, a hyperbola, a parabola, or a line? Circle? But there's no exponential thing in circle. What should I do? To write this expression as an like equation of a circle.
You take ln on both sides.
Yeah, if you take ln on both sides, the left hand side would be x square plus y square if you know some properties of logarithm. Right hand side becomes natural log of c. That's why there's a restriction that, the restriction is c is less than 1. What happens if c is less than 1 here? What is natural log of something which is less than 1? Like, to be honest, I don't remember these values, and why should I? If you only remember the graph of this natural log function, I think that should be enough. So at 1, the value of natural log or any log is 0, whatever the base is. And then for any value which is bigger than 1, it increases. For any value which is smaller than 1, it decreases. At 0, the value of natural log is negative infinity because it goes down. At 1, the value of natural log is 0. At 1, the value is 0. Okay? So in between 0 and 1, the value is always negative. And if any number is less than 0, the natural log, the value of natural log does not exist. Because you cannot define logarithm of any value which is negative. But if the value is between 0 and 1, natural log of that number is always negative. Now what happens if x square plus y square is equal to a negative number? I think we discussed this thing maybe for a couple of minutes. So this is a what? It's nothing. Okay? X square plus y square is equal to radius square. If that radius is a positive number, we can make sense of these things. If radius is exactly 0, x square plus y square is equal to 0 gives you a point. A point means a circle whose radius is 0. But if the number is negative, it means you are not getting anything. Why is that so? Because if you try to graph this function, e to the x square plus y square in this 3 space, the function always looks like a parabola like this, for example. But it's always a parabola which is above z is equal to 1. So if you try to intersect with any plane where the value of z is less than 1, because this is our z. If z is less than 1, it means there is no any intersection. If there is no any intersection, we are not going to get any circle. But if you take the value which is greater than 1, there will be intersections and you will see different values. So this is geometric meaning. And if you don't like geometry, this is like algebraic meaning that if c is less than 1, it doesn't make any sense. This is similar to what I discussed, so I'm not going to talk about this one. This question is a bit technical. And the question is, okay, if you take f of xy is equal to 2, how does the graph of this function look like? So I'm not talking about these graph of functions of 2 variables. If you think of this function, this is a function of 2 variables. Okay, because y is equal to some function of x, not 2 variables, 1 variable. So how to graph this function? So I don't think this question will be there on exam, but it's very surprising to know that the graph of this function looks like a diamond, centered at origin, and this value is 2, and this value is negative 2 in x-axis, and this value is 0, 2. This value is 0, negative 2. Like this should be 2, 0, and this should be negative 2, 0. So this is going to be an exercise for you to check why this is so. Okay, how about this thing, xy is equal to 10. Is it a circle, a parabola, a hyperbola, a line? Let us apply method of elimination. Obviously it is not a line, because the degree of this expression is x times y. This is a single expression. What is the degree? Like, is it linear or not? It means the degree is not 1. Why is it not 1? You are multiplying, you have x raised to 1, y raised to 1. If you multiply, you add their exponent, so the degree is 2. Okay, so is it a circle? Does it look like a circle? A parabola? Parabola is always y is equal to x squared times something. So obviously not. So it should be a hyperbola, but this is like the equation of hyperbola that we know. It looks like this one, x squared minus y squared is equal to some constant. So this is a pretty common equation. Like as I discussed already, like if you have positive signs, circle or ellipse, if you have negative sign in between, this is going to be a hyperbola. But this is a bit different. What happens that I think you know this function, because this function is y is equal to 10 over x. So if you don't know function y is equal to 10 over x, I think at least you know what is a function y is equal to 1 over x look like. So it's like this one. So these are like two disjoint curves, and these disjoint curves look like a hyperbola. What is the difference between this hyperbola and this hyperbola? This one is a bit rotated. Like if you rotate it back, maybe it looks like this one. So you take that hyperbola and rotate it, it will look like that. But we know that how the graph of y is equal to 1 over x look like, that is that one. How the graph of y is equal to 10 over x look like, it will be similar to that one, just a little bit stretched or dilated from some point. What would be the difference? At 1, the value is 1, but for y is equal to 10 over x, at 1 the value would be 10. So it would be something like this, very big value here. Okay? And similarly, very small value here, negative 10. But it will be a hyperbola. Okay, so there would be a question where you will be asked about some simplifications, like finding a value from the function is not a difficult thing to do, and how to simplify and state the restriction. The restriction is x should not be equal to negative y. If you put the value of x to be equal to the value of negative y, obviously this thing is not defined. Or in other words, x plus y should not be equal to 0. This is a restriction, and this restriction helps us to find out the domain of many functions. You might have done in other courses, like if I give you this function and I ask you what is the domain of this function, maybe the answer is really simple, that the value of x should not be negative. So the domain of this function and all the values of x which are greater than or equal to 0. Or the domain of this function is from 0 to infinity, where 0 is included. And similarly this one x should not be equal to 2. And also we can talk about what is the domain of this function in a similar way. And why we are talking about the domain? Because if the value of x and y does not lie in the domain, we do not have function in that particular domain, and we will not be able to talk about continuity or limit in that domain. So one thing is, if I give you this function, natural log of x divided by x, like I'm not talking about these multivariate functions, I'm talking about a function of one variable. Let's say this is equal to y. And I ask you what is the domain, what would you do? Domain of a function, I think it's very basic thing. But instead of a function of one variable, we have functions of two variables. So that's a basic difference. So how do you do this thing? Fine. Can I put x is equal to 0 here? What's the reason? Divide, okay. So there are a few common things. You always look at what is in the denominator. You always look at what is in the square root. And you always look at the functions. Three things. So denominator should not be 0. It means the value of x cannot be 0. And then there is no square root in this function. The third thing that I have to look at, what is the function? So the function involved is natural log. And I know that inside natural log, the value of x cannot be 0 and cannot be negative. So it can be either, like, it is always a positive value. So by using these two things, obviously I know that the value of x should be greater than 0. I can do a similar trick with this function. X minus y should not be equal to 0. This is one thing. It means x is not equal to y. So in this expression, you cannot put a pair where the value of x and the value of y both are same. We can't do this thing. And what about natural log? Obviously this expression should be greater than 0, whatever inside the natural log is. It means x square plus y square is less than 5. Okay, so sometimes if we want to write domain in a very simplified form, then we say that, okay, these are all the pairs x, y, such that x plus y is not equal to 0, and x square plus y square is less than 5. So you can put all the values such that these two conditions are satisfied. Okay, so these questions I think are not too different from what we discussed. Okay, the next one is I'm given this function. I'm asked to compute some values. Obviously, this is a very simple thing to do. How to answer this question? I'm given a function, describe the cross section parallel to xz plane. We are always talking about cross sections. So the cross sections that we are talking about is, we are taking a plane which is parallel to xy plane. Because if you draw these three x's, this is y, this is x, this is xy plane, and we always intersect with a plane which is parallel to xy plane. For this thing, what do? We put z is equal to c. This is what we do. So we talked two different things. One thing was like, how can we talk about cross sections? Okay, you do a cross section where you cut a surface with a plane which is parallel to some plane, xy plane, xz plane, or yz plane. So if we are intersecting with a plane which is parallel to xy, we'll substitute z is equal to c. And if we intersect with a plane which is parallel to yz, we'll put x is equal to c. And if we intersect with a plane which is parallel to xz, which is that one, for example xy, then we'll put z is equal to c. So these are three different options. So we are going to intersect with any plane that is parallel to some basic plane, and there are three basic planes, xy and yz and xz. So I think it's very simple. What should I do here? You know that this f is equal to z. So z is equal to x, c square plus c. Not c. Agree? So you take this surface, intersect with this plane y is equal to c. This plane is parallel to xz. You will get this curve. This is a curve in xz plane. Okay? So now the question is, okay, Describe this cross section. Obviously, this cross section is 1 plus c squared times x. So this is equation of a line. Okay. Z is dependent variable, x is independent variable, x is multiplied by something. This is equation of a line in xz plane with slope 1 plus c squared, because that is m here. That is what do you mean by describing. So you put the value of that particular quantity and describe how the like resulting curve look like. And similarly, what should I do here? Z is equal to agree? And this is an equation of a parabola. Okay. If you specify C, then you can also specify how does that parabola look like. For example, if C is equal to 0, then there will not be any parabola. It will be a single point Z is equal to 0. Okay. Z is equal to 0 might correspond to a line or a plane as well. And x is equal to 1, for example, not C. Let's say the value of C is 1. Then this is z is equal to y square plus 1. Obviously, this is a parabola in yz plane, which is shifted 1 unit upwards in z direction. Yeah.
Is the test gonna have like free response questions like this, or is it gonna all be multiple choice?
Both.
Okay,
Yeah. Is this question a free response question?
I think because you're like writing them the answer.
Like, if you put the value of c, there's no free response. You have to write it's a parabola. If you write it's a circle, obviously it's wrong. If you write it's a hyperbola, it's wrong. But you can write whatever you want. If I find the word parabola there, it means you're right. Okay. You can write a couple of sentences describing the situation, what is happening, but yeah, it's up to you. Okay, so whenever like a question which is about these cross sections, there are 3 different options. You look at those options, which is like xy plane, xz plane, and yz plane. If it is xy plane, put the value of z is equal to some constant. If the value of z is given, that's good. Otherwise, just put z is equal to c. Xz plane, it means y is equal to c. Yz plane, it means x is equal to c. Okay, but in this question, it is specifically given that, okay, find the cross section when y is equal to 1 and when y is equal to negative 1. So you put y is equal to 1 and then you put y is equal to negative 1 to see what happens. Okay, and what is y is equal to 1? In our context, this is a plane. Okay, we know that z is equal to c is a plane that looks like this. Obviously, y is equal to 1 or negative 1 is a plane that is vertical and that looks like this. This is similar. You know contour diagrams. I think this is a simple job to do. Sketch a contour diagram for each function, at least 3 label contours. And what do we mean by that? You put f is equal to some c, like we are intersecting with z is equal to c. We are not intersecting with y is equal to something or x is equal to something. So this is going to be 2y minus x square is equal to c. So what you can do is, the simplest thing is if you want to sketch these contours, you write this thing in this way, 1/2 x squared plus c. Write the explicit form and then choose different values of c. For example, if you choose c is equal to 0, you will get y is equal to 1/2 x squared. And obviously, this is a parabola from the origin. If you choose c is equal to 1, it is going to be 1/2 x squared plus 1/2. Okay. Yeah, 1/2. So what is this? This is a parabola which is shifted half units up in the y direction. So this is 1/2 and This is second curve. And then you put c is equal to 2, you get another curve. So you don't need to draw these curves like with perfect values and perfect grid, as long as they look like a parabola and you are giving the idea that if you take c is equal to 1, it is going to be shifted, it should be fine. Like you don't need to make a grid and choose the values and plot the points and join the points. It's going to take a lot of time, and you won't be having enough time, to be honest. Okay, so a question about contours. A function is given. This can be any crazy function. We don't need to worry about that. Make it equal to c, choose different values of c, draw contours. That's it. Obviously, you have to think about, can I choose positive value, negative value, or 0? For example, in this one, you can also choose negative values. It doesn't make any difference. I think it's going to be shifted downwards if you choose a negative value. But if it is a circle and the equation has a specific form, maybe you can't choose c to be a negative value. Okay, and that is simply this equation. The contours x square plus y square is equal to c. If you choose c is equal to 0, that's a point. If you choose c is equal to 1, that's a circle with radius 1. C is equal to 2, that's a circle with radius square root of 2, and so on. Okay? So you can't choose c to be negative 1. And then you need to write, okay, this is corresponding to c is equal to 0, and this is 1, and this is 2, and so on. Okay? So I'm like explicitly telling you how the questions in exam look like, and if you do practice on at least these questions, that should be I think 80 to 90% enough. Okay, this one, I think this is same question. Yeah, so I'm just leaving these for now. For each function, describe the family of level curves. Yeah, this is a similar question, but this says that, okay, x square, this is my z, and x square is equal to c. Let me write it k. As they are saying, like, describe this family of level curves when k is a positive number and when k is 0. So what do you think? X square is equal to k in xy plane is a level curve. If I put k is equal to 0, it means x square is equal to 0. It means x is 0, which is a point. Is x is equal to 0 a point in xy plane? X is equal to 0 is an equation of this vertical line, which is y-axis. Okay? X is equal to 0 is an equation in this 2 plane, which is corresponding to y-axis. And then if you put k is equal to 1, then this is x square is equal to 1, which gives me the value of x to be positive negative 1. It means I need to draw 2 lines, one at positive 1 and one at negative 1. So for each value of k, I get these lines which are vertical in this xy plane. Okay, and if k is equal to 2, then you will be having x is equal to plus minus root 2. Then you will be having like 2 other vertical lines. So the contour is like family of these lines in xy plane. Why is there a family of lines? I think if you remember, this is x-axis, y-axis, z-axis. This is basically z is equal to x square. So this thing is nothing but a parabola in x and z axis, which looks like this. But remember, we know that if one variable is missing, this is a family of parabolas, and if they are joined together, they make this parabolic cylinder. Okay? Then if you intersect this thing with any plane, any horizontal plane, for example, the plane looks like this, it intersects this curved surface at two lines exactly. One line here and one line here. And if you project it down, you will get two lines in xy plane. I don't know whether it should be rotated or not, but this is the idea. No, it should be rotated. It's not right. Okay, so I should draw it in. So it should be transported in this y-axis. So for now, if you assume this is y-axis and this is x-axis, then the things are okay. Okay? But I can't do this thing. I just did it. Yeah.
So the answer to that question would just be the graph?
Obviously, you draw the graph and you write this is a family of lines which are parallel to y-axis or which are perpendicular to x-axis. Yeah. You can describe in words whatever you like, but I think if you at least write this thing, whatever I have written, that should be okay. At least if you write one sentence, that is good. If not, then it doesn't make any difference. Yeah. Okay, so I think everything else is really similar to what I'm discussing. We already did this question in our quiz. So I'm giving you 3 points, but the restriction is out of these 3 points, you can put 2 points such that the x value is same. You can use those 2 points to find slope in y direction. And then you can pick 2 other points whose y value is same. You can use those 2 points to find slope in x direction. Then you should at least know the equation of plane where you know the slope in x direction, you know the slope in y direction, and you know at least 1 point. Okay? So this was, I think, one of the simplest questions on quiz. But it's still like there were few where I saw that, okay, at least they didn't get the idea what are we doing. Okay? So the first thing is you have to choose the right points. Once you have chosen the right points, then you can always do this slope formula and put the values. So I'm just explicitly telling you that, okay, there will be one question similar to this. There will be different points, whatever those are, but obviously the idea would be same. And maybe a question like this. So instead of 2 points, instead of 3 points, we are given 2 points. And we are given slope in x direction. It means this is value of m. So obviously, I need to use these two to find slope in y direction. Can I do this thing here? Can I use these 2 points to find slope in y direction? The answer is yes. And why? Because the x values are same. Yeah. So if not, then we can't do this thing. So x values are same. You can find slope in y direction. You are already given the slope in x direction. And you can choose like one of these points, use the formula and find the equation of plane. But there's also other question which is find where it intersects the xy plane. It means I should substitute the value of z to be 0. Why 0?
Because that's where the xy
Yeah. Yeah, so these are like small things that you should know when you're trying to talk about these things. Okay, so what is happening that whenever we are intersecting with any plane which is parallel to this xy plane, we are substituting z is equal to c. So you can change the value of c. If you increase it, it goes higher in space in z direction. And if you choose the value of z to be exactly z is equal to 0, it means you are on xy plane. Okay? So z is 2, 3, 1, whatever it is. If you take it down to 0, it means you are exactly on xy plane. So what is this? Obviously, this will be equation of a plane, whatever we get from here. And that equation might be something like this. And xz is another plane, and this is the plane that we are looking at is this oblique plane, for example. Their intersection is a line. Okay, and then you need to find that line. So what do you need to do? As an example, I'm writing the equation that is coming from this plane is 2x plus 3y plus 1. It's an example. Intersection with xy plane is you substitute z is equal to 0. So you get 2x plus 3y plus 1 is equal to 0, which is equation of this line, this one. Okay? You don't need to draw these. At least you find the plane, you put z is equal to 0, you get something. This is the intersection. That's it. This is similar. This too, and you're talking about question number 7. This was question number 7. I think someone asked, and I hope it answers. Okay? Yeah. So question number 8 is, yeah, this is a bit technical. But I think we did like enough problems in our last lecture on this chapter to talk more about limits. The question is, compute the limits along y is equal to 0 and along y is equal to x. Does this limit exist? So there are 3 questions here. First, we have to do this thing, and y is equal to 0 is a line, and we are going to find the limit along this line, y is equal to 0. Yeah. So whenever you find such a thing, you simply substitute y is equal to 0. So this will give you 0 divided by x square plus 0 square, which is 0. Now if you find the limit, obviously the answer is 0. Okay? So you can write limit of the function but y is explicitly 0, so x comma 0 goes to 0, 0 of 0 is equal to 0. And how about this thing? You see that what happens if you substitute y is equal to x. So this is x times x. X square divided by 2x square, which is 1/2. Now if you do the same business, the limit will be equal to 1/2. So limit along this line is 0 and limit along this line is 1/2. So we can conclude that the limit does not exist. Because if the limit exists, it means along every line the limit must be same. But I chose 2 specific lines and the limit is not same. So the limit does not exist. So if it is like directly asked that find that whether this limit exists or not, I think it's a difficult question. But you know a trick that you can do y is equal to mx, and then if the final answer is a fixed number, then the limit exists and that is a limit. If the final answer depends on m and you choose a different value of m and it gives you a different limit, it means the limit does not exist, obviously. This is one simple way to check. And this is also a similar question. this one as well. Compute the limit along y is equal to 0. So y is equal to 0, the limit will be equal to 1, and y is equal to x, the limit will be equal to 0, so the limit does not exist. Okay. How can we decide whether this function is continuous or not? Yeah. Say it again. Yeah, it means the value of the function is same as its limit at that point. Okay, so we are looking at continuity at 0, so we don't need to worry about continuity of the function in general. Okay, so at 0, the value of the function is 0. Now just find that, okay, whether the limit of x square y divided by x square plus y square is 0 or not when xy approaches 0, 0. Okay, and you can do this thing by using the method that we discussed, which is y is equal to mx, and then see what happens. I think this is same as function f or g that we already discussed in our class. This is same function. So I have 5 minutes. Let me see. Yeah, I have a couple of things, so I don't want to waste time there. And we also discussed a question similar to this one at the end of section 12.6. What you can do is you can take x square plus y square to be equal to r, or in practice we take it equal to r square, but let's say it is r. Then this function will be 1 minus cosine r divided by r. And whenever x, y both go to 0, it means r goes to 0. So the limit of this actual function, this star, is xy go to 0, 0, is same as this limit. And I think you know from Calc 1 that this limit should be equal to, or you can use L'Hopital if you want. I think this should be equal to 0. The derivative of 1 is 0, cosine is negative sign, so this is sine, and the derivative of r is 1. If you apply r goes to 0, sine of 0 is 0, yeah. So it is 0, you can use L'Hopitals. So what does it mean? It means that the limit is 0 and actual value of the function at 0 is c. Whenever these things are equal, it means the function is continuous. So the value of c should be 0. Okay? Then I think in one of the sections we also discuss about functions of 3 variables, but we cannot graph these, but we can always graph the level surfaces coming from functions of 3 variables. One example is this simple example. If I do this thing, then what happens? Level surface corresponding to G is equal to C. So we need to think about what is this particular surface. So obviously this is nothing but x square plus y square minus z is equal to natural log of c. Or z is equal to x square plus y square minus natural log of c. What does this surface look like? So function of 3 variable, we cannot draw it in this 3 space. We need 4 space. We don't know how to do 4 space. So this is one of the level surface corresponding to one value of c. So what happens if like c is equal to 1, then natural log of 1 is 0. So this is z is equal to x square plus y square. And we know that this is a paraboloid. Okay, this is a paraboloid. And sorry, not paraboloid. I think we can describe more, but it is enough. If you just subtract some value, it means you are taking it like down in z-axis, in the negative z-axis. Okay, but it's a parabola. It's a paraboloid. Is there a level surface for g is equal to 0? Can I put g is equal to 0? It means, can I do this thing? If I do this, then I take natural log on both sides. So natural log of 0 is negative infinity. So I can't do this thing, okay? So not possible. So I cannot explicitly geometrically show you why this is not possible, but one reason is if you draw a surface which is in some 3 space that looks like this, it's like a hill type surface that looks like this. This is my z-axis, this is x-axis, and this is y-axis. This surface goes down and approaches xy plane but never touches it. Okay, so it's like a hill type surface, but it goes down but never touches xy plane. So you cannot intersect this with any plane which is this xy plane, okay, because there will be no intersections. Okay, so I'm done with my time. Just give me which one should I discuss? That is, yeah. So these questions are really what we have done in our class. But whenever you find something like this, you can take this inside quantity to be equal to r. Then this whole problem will reduce to limit r goes to 0, sine of r divided by r, and you know that this thing is equal to 1. That's why these inside quantities are similar here. You can do a similar thing here. Take x square plus y square is equal to r. Or take r is equal to square root of x square plus y square. Then the denominator will be r and numerator will be r square, which will be r. So if you take limit as r goes to 0, this becomes 0. I'm going a bit quick, so there might be typos or maybe I'm simplifying somewhere a little bit wrong. So yeah, so that's it. So just do practice on this one and I think it should be enough.